Hello friends, today we are going to complete remaining topics of packages and interfaces, that is theory part 2. We were learning about packages in previous session. After that the next session we are going to take. If a class with same name exists in two different packages that you import using a star form, the compiler will remain silent unless you try to use one of the classes. For example, if you are trying to use a class from class package ABC and package EFG, and both are having same class name, and that you want to use in your your own class. So unless and until you are going to use that particular class, that class is existing in both the packages, in ABC also and in EFG also. When you will try to use that particular class, then only compiler will give you compile time error. Until then, compiler will remain silent. In that case, you will get a compile time error and have to explicitly name the class specifying its package. It must be emphasized that the import statement is optional. Any place you use a class name, you can use its fully qualified name which includes full package hierarchy. You can directly import statement is optional. Like you can directly use a class like package1 dot package2 dot package3 dot class name in your project. So using import statement is not compulsory. For example, this fragment uses an import statement, import java.util.star. So whatever classes are present in java.util package, those will be imported in this project. My class myDate extends date. The same example without import statement will look like this. Class myDate extends java.util.date. So without using import also you can use the java.util.date. Date is fully qualified, that is having the full package hierarchy. Package1 dot package2 dot class name. As shown in table, when a package is imported, only those items within package declared as public will be available to non-subclasses in the importing code. So whatever is declared public in the particular package that we are importing, those only will be available to non-subclasses in the importing code. In this version, date is fully qualified. For example, if you want the balance class of package mypack shown earlier to be available as a standalone class for general use outside of mypack, then you will need to declare it as public and put into its own file as shown here. So in previous example, we saw a balance class in the my package, and if you want to use that particular balance class outside of my package, you should declare it as public, as we have seen in the access specified table. Package my package. Now the balance class, its constructor and its show method are public. This means that they can be used by non-subclass code. Public class balance string name double balance. Public balance string n double b. This is the parameterized constructor of this class. Then name is initialized to n, balance is initialized to b. Then if balance is less than 0, then print name and $balance. Balance is now public. It is public class balance, so it is available outside of package mypack. Then also its constructor and show method are public too. Here it is declared as public. Here it is declared as public. This means that they can be accessed by any type of code outside the mypack package. For example, here test balance imports mypack and it's then able to make use of balance class. Test balance, it's non-public class default access. Because balance is public, you may use balance class and call its constructor. Balance test is equal to new balance. Here you are inputting mypackage.star. All classes in the my package are imported, and since my balance class we have declared it as public, it can be used here to create the object of balance class. Then we are passing you two variables. First is string n, second is double b. So while creating object, we are giving JJ Jaspers as the name and 99.88 as a double value. Then test.show, show is also public. You can also call show method. It is inside the package, my package. Remove the public specifier if you want to try from the balance class and then try compiling the test balance. Error will result. Compile at time, error will occur. Now we will see the next topic of packages and interfaces, that is called as interfaces. Using the keyword interface, you can fully abstract a class interface from its implementation. That is, using interface, you can specify what class must do, but not how it does it. Okay, so only declaration, not definition, like an abstract class. Interfaces are syntactically similar to classes, but they lack instance variables and their methods are declared without any definition or without any body. So instance variables or members like data types, variable names, like this, it is not there in interface. And also whatever method you will write in interface, it will be only its structure, not body will be present, not definition of method, only declaration, like an abstract class. In practice, this means that you can define interfaces that don't make assumptions about how they are implemented. Don't make assumptions means they don't know or they don't assume how they will be implemented. Once it is defined, any number of classes can implement an interface. Also, one class can implement any number of interfaces. While in the first session, when we started this chapter, in the previous session and in the previous slide, we have seen that interfaces, one class can implement in any number of interfaces, but one class cannot inherit more than one abstract class or non-abstract class. This is the basic difference between interface and abstract classes. To implement interface, class must create the complete set of methods defined by the interface. However, each class is free to determine the details of its own implementation. So any number of classes can implement any number of interfaces, but they are compulsory to, if they are implementing that interface, they should be compulsorily define the complete set of methods, all methods in that interface. But whatever they will write in that particular definition of method, it is dependent upon that class. So each class is free to decide what should I write to perform the operation for this particular method. By providing the interface keyword, Java allows you to fully utilize the one interface, multiple methods aspect of polymorphism. And interfaces are like dynamic method resolution at runtime. In order for a method to be called from one class to another, both classes need to be present at compile time. Like both classes should be present at the compile time, so the Java compiler can check to ensure that method signatures are compatible. So at compile time, both should be present, and a Java compiler will check to ensure that method signatures are compatible. This requirement by itself makes for a static and non-extensible classing environment. Like at compile time, both classes should be there, and Java compiler check to guarantee that method signatures are compatible. Whatever you have declared in the interfaces, that same definition you are writing in your class. Like if, for example, if in your interface there is a show method and it is returning nothing, it is void show method. But in your class that you are implementing show method, but it is returning integer. So exact match is not there. For that purpose, compile those classes, both classes need to be present, so that a compiler will check that method signatures are exactly matching. Inevitably, in a system like this, functionality gets pushed up higher and higher in the class hierarchy, so that mechanisms will be available to more and more subclasses. interfaces and design are designed to avoid this problem. Every time functionality gets pushed up higher in the class hierarchy, so that all the classes, all the subclasses should get the methods to be implemented in their own classes. To avoid this problem, interfaces are designed. They disconnect the definition of a method or set of methods from the inheritance hierarchy. So they only provide the declaration in interface, and every class is free to define what should be written in that particular method. Since interfaces are in different hierarchy from classes, it is possible for classes that are unrelated in terms of the class hierarchy to implement the same interface. Interfaces, it does not present. Interfaces does not present in the class hierarchy. They are independently written. Okay, when we will see in the example, when creating interfaces, we create a class like file, new project, and that right click on that particular project, new package, right click on that particular package, new class. But in that class, you will not write interface. For the we will right click on that package and then you will create a interface. So interface is written separately. It is not present in the class hierarchy, so it is independently written. So whatever class needs to implement that particular interface, they will write it as class name, implements, interface name. Okay. So it is independent, and you no need to remember the hierarchy of classes. Since interfaces are different in a different hierarchy from classes, it is possible for classes that are unrelated in terms of the class hierarchy to implement the same interface. So many classes can implement the same interface at a time. This is where the real power of interfaces is realized. Interfaces add most of the functionality that is required for many applications that would normally resort to using multiple inheritance in a language such as C++. Multiple inheritance is not present in Java. It is removed from Java. Okay, why it was removed from Java? When one class inherits more than one superclass, what will happen? For example, show method is present in class A. Show method is present also in class B. And class C is inheriting both class A and class B. So compiler will get confused. Which show method I should use from class A or class B. So interfaces is designed to overcome this problem, so that in Java it will be possible to implement the multiple inheritance also, and this type of conflict will not occur at the same time. So interfaces add most of the functionality. Like interfaces, first of all, it is declared independently in a separate file. Then so many classes, whatever number of classes, can implement whatever number of interfaces, and this conflict will not occur in that case. So it is same implementation such as in C++, but only a difference it is written in Java, and a separate file is created called as interfaces. Defining an interface. How to define? Just remember it. It is much like a class. This is a general form of interface. Access specifier, interface name. You no need to write the complete. Here you are free to write access specifier, interface, and its name. Return type method name, one parameter list, return type method name, two parameter list. Type final variable name value. Type final variable name is equal to value. And up to return type method name parameter list. Type final variable name is equal to value. When no access specifier is included for interface, then default access result, and the interface is only available to other members of the package in which it is declared same as your same rules as for your classes and data members and member functions. When it is declared as public, the interface can be used by any other code. In this case, the interface must be the only public interface in the file, and the file must have the same name as the interface. When interface is declared as public, first of all, you will write interface in a separate file. Have you understood this? After that, what will happen? If you are writing that particular interface with public access specifier, its name must exactly match the name of interface and name of Java file, and it must be the only public interface in that file. Okay, name is the name of interface, and it can be any valid identifier depending of the rules of identifier. Notice that the methods that are declared have no bodies. No definition of the method is present. They end with the semicolon after the parameter list. They are essentially abstract methods. There can be no default implementation of any code, any method specified within an interface. Abstract method are much similar to abstract methods they are. There can be no default implementation of any method specified within an interface. And for no reason, you cannot define any method present in that interface as same as abstract method. Each class that includes an interface must implement all of the methods. So there are two rules. In interface, you must not define the method, and in a class, second rule is in the class that you are implementing interface, you must define that particular method. Variables can be declared inside of interface declarations. So variables are allowed in interfaces. They are implicitly final and static, meaning that they cannot be changed by the implementing class for any reason. They must also be initialized. Why? Because they are final. All methods and variables are implicitly public. Example, it declares a simple interface that contains one method called callback and that takes a single integer parameter. Interface callback. This is the example of interface. Interface callback. No access specifier is written over here. What does this mean? This means that there is a default access specifier. Default access specifier, then interface keyword, then interface name, and one method, callback method, void callback integer parameter. Implementing, and what is the rule? All methods are implicitly public, and this is the example. Implementing interfaces. Once an interface has been defined, one or more classes can implement that interface. To implement an interface, include the implements clause in a class definition, then create the methods defined by the interface. Create and define those methods. The general form of class that includes the implements clause look like this. Class, class name, extend superclass, it is allowed. Implements interface 1, interface 2, interface 3, up to interface n. And then class body. If a class implements more than interface, the interfaces are separated with a comma. If a class implements two interfaces that declare the same method, then the same method will be used by clients of either interface. This is the rule. Like if conflict is occurring, if a class is implementing two interfaces that declare the same method, then the same method will be used by clients of either interface. The methods that implement an interface must be declared public. All those methods that implement that interface must be public. Also, the type signature of the implementing method must match exactly the type signature specified in the interface definition. Otherwise, it is not called as implemented method or defined method. So this rule is very, very important. Type signature like void show written in your interface, and in your class that implementing that method you are writing integer show that it is not allowed in that case. Here just small example that class callback, class client implements callback. Callback interface we have already defined. Implements callback interface public void callback integer parameter integer p. Callback called with p. So here how we are defining this method? We are just simply printing the value. Callback called with p. Notice that callback is declared using with the public access specifier. So whatever method you are writing over here, defining over here, it must be public. While defining, we have not written here public. It is default access specifier. But while implementing, it is compulsory that you should be writing it as public access specifier. When you implement the interface method, it must be declared as public. It should be remember. You have to remember this. You have to note it down. It is both permissible and common for classes that implement interfaces to define additional members of their own. So classes, whatever classes that are implementing particular interface, they can add their own member variables and member functions. The following version of client implements callback and adds method, non-interface method, which is its own method. Class client implements callback, void public void callback parameter, callback called with P. Non-interface method, classes that implement interfaces may also define other members too. So it is allowed in that case. Accessing implementation through interface references. So here also reference variables are occurring. You can declare variables as object references that use an interface rather than a class type. And any instance of any class that implements the declared interface. Any instance means any variable of any class that implements the declared interface can be referred to by such a variable. So what you can do, you can declare variable as object references that use an interface rather than a class type, and any variable of any class that implements a particular interface can be referred to by such a variable by using such a reference variable. Like an example we have seen in previous session, we can create one reference variable, and using that reference variable you can access any variable of any class that implement a particular interface. When you call a method through one of these references, the correct version will be called based upon the actual instance of the interface being referred to. This is the one of the key features of interfaces. Okay, so how it will be called? When you call a method through one of these references, you can create as many references as you can, as many reference variables as you can, as you need or as you want. The correct version will be called upon what? Based upon actual instance of the interface being referred to. Because dynamic lookup of a method at runtime incurs a significant overhead when compared with the normal method invocation in Java, you should be careful not to use interfaces casually in performance critical code. Whenever you are having a dynamic lookup of a method using the reference variables, when you are using the reference variable, method will be looked up at runtime. So that causes the creates the time complexity, that adds the time, that increases the time required, so that it creates the significant overhead related to time as compared to normal method call. You should be careful not to use interfaces casually in performance critical code. Not only related to reference variable it is telling you for the use of normal interfaces. In normal interfaces also, when you are calling a particular method like a normal call, and when you are calling a particular method from that interface, every time compiler will have to check whether that class is having implemented that interface. Yes. Whether that interface method type signature and the method that is implemented in this class, both type signature is same. Yes. Then it will call that particular method. So it will add the time complexity. So most of the times, whenever it is possible, try to avoid the interface usage. The following example calls the callback method via an interface reference variable. Now, test iFace is a class for public static void main. Here we are calling callback C is equal to new client C dot callback. callback called with 42. So callback C, interface reference variable, callback is a interface and is equal to new client whose object is created, object of class client. This is a class client and this was the interface we have created, callback. Okay, interface callback and then class client. So reference variable is created like this, callback C is equal to new client and C dot callback 42. So this will call the callback method from client class. If there is one more class, for example, um, super, for example, super class is for example, then we are creating object of the callback like reference variable of callback like this, callback C1 is equal to new super class, then C1 dot callback 45. So it will call callback method from class what, super class. Depending upon the object you are passing over here, it will call that particular method. Notice that variable C is declared to be type of interface type callback, yet it was assigned an instance of client. Although C can be used to access the callback method, it cannot access any other member of the client class. C can be used to access the callback method. Any other members? Why any other members are not allowed? Because whatever is written in that particular interface, and that particular method that written in interface and it is implemented in class, only that particular method is accessible, or any final variable, static variable is accessible. Whatever is written in the interface, only that particular variables and member functions are accessible through the interface reference variable, not any other members. That is, non-interface methods and variables are not accessible through the reference variable. Interface reference variable only has knowledge of the methods declared by the interface declaration. Thus, C could not be used to access non-interface methods since it is declared by client but not the callback. While the preceding example it does not demonstrate the polymorphic power of such a reference. First, create a second implementation of callback. Class another client implements callback. Here, public void callback implementing the callback method of interface. Then another version of callback, p squared is p into p. Now test interface 2, another client object OB is equal to new another client and C dot callback 42. C is equal to object. Now C is a reference variable and it is referring to object. C now refers to another client object C dot callback 42. So now it will call the another version of callback and it will print p squared is p into p. It's 1764. The version of callback that is called is determined by the type of object that C refers to at runtime. While this is a very simple example, you will see another more practical one shortly. Then nested interfaces. Interface can be declared a member of a class or another interface. So one interface can have another interface inside it. Such an interface is called a member interface or a nested interface. Like a nested class and nested for loops, we can have nested interfaces also. A nested interface can be declared as public, private, or protected. This differs from a top-level interface which must either be declared as public or use the default access as previously described. Nested means inside interfaces can be public, private, or protected, but the outermost interface must be at either default or public, because to access the inside interfaces, inner interfaces, the outer must be accessible at all times. When a nested interface is used outside of an enclosing scope, it must be qualified by the name of the class or interface of which is a member. When a nested is used, Nested interface means inner interface is used outside of its enclosing scope, means outside of the scope in which it is written. It must be qualified by the name of class or interface of which it is a member, like interface name dot interface name. Thus, outside of the class or interface in which a nested interface is declared, a name must be fully qualified. Fully qualified name means interface class name dot my inner interface name, outer dot inner, like this. Public interface nested if boolean is not negative integer x. Then B implements nested interface. B implements A dot nested interface. Why it is written it like this? Because A is a 5. Class name dot interface name. A dot nested interface. Okay. So to implement this, public boolean is non-negative. If x is greater than less than 0, then it is false. Otherwise, it is true. Class nested if demo, public static void में A dot nested if object is created. Now n interface new B. Sorry, it is creating a nested interface reference. A dot nested interface n interface is equal to new B, object of type B. If n is non-negative, 10 is non-negative. If n is non-negative, then it is going to be displayed. A defines a member interface called nested if and that is declared as public. Next, B implements the nested interface by specifying A dot nested if. Name is fully qualified like class name dot interface name. Inside a main method, A dot nested if reference called nIf is created and is assigned a reference to a B object, so that in that particular way it will call the B's methods. Because B implements A dot nested if, this is legal and this is allowed because interface nested if method is present. Then applying interfaces to understand the power of interfaces, we will see an example. You develop a class called stack, simple fixed size stack. There are many ways to implement a stack. For example, stack can be fixed size or growable. The stack can also be held in an array, linked list, binary tree, and so on. No matter how it is implemented, interface to the stack remains the same. Basic implementation will always remain the same. Methods push and pops define the interface to the stack independently of the details of the implementation. Because the interface to a stack is separate from this implementation, it is easy to define stack interface, very much easy, only to define push and pop, leaving it to each implementation to define the specifics. So one interface will have push and pop methods, and every class that is using that stack interface or implementing that stack interface can independently define its own methods. Now, interface stack, void push, integer item, integer pop. Now, fixed stack implements integer stack. Two variables are private, stack array and top of stack. Then allocate and initialize stack, fixed stack, integer size, stack is equal to new size, top of stack is equal to -1. Now push an item into the stack. So this is implemented by the class fixed stack. Okay. If top of stack is equal to stack dot length -1, stack is full. Else stack and increment the value of top of stack and then put the item. Then pop, as we have already seen, pop the element of the stack and then minus or decrement the top of stack by 1. Then in if stack, if test, we are creating object of fixed stack. Two stacks are created, pushing the items and popping the items of the stack. Now we will see another implementation of in stack that creates a dynamic stack by use of same interface definition. So each stack will be constructed with an initial length, and if that initial length is exceeded, then the stack is increased in size. Each time more room is needed, the size of stack is doubled. Dynamic stack implements integer stack. Two arrays are there, private, one array, one top of stack, private. Then dynamic stack integer size. It is a parameterized constructor. Stack is equal to new integer size, top of stack -1. So remaining example we will see in the next session, and we will cover the all remaining topics in that way in that session. So meet you in the next session. Thank you so much.